Figure 12 shows the graph of y equals 1 over x minus 2. Part I. Draw accurately the graph of y equals 2x plus 3 on the copy of figure 12 and use it to estimate the coordinates of points of intersection between y equals 1 over x minus 2 and y equals 2x plus 3. So to draw y equals 2x plus 3, it has a y-intercept of 3. So it's going to intersect here, and it's got a gradient of 2, which means I'm going to move along 1 square in the x direction, and I'm going to move 2 squares in the y direction. So it's going to look something like this. There we go, that's better. Right, I need to use this to estimate the coordinates where these two lines intersect. So, I can see that they intersect here and here. So let's read off those coordinates then. So the x coordinate there, I think, is about 2.1. The y coordinate there, so the y coordinate there, I think, is about 7.3 by my reckoning. And for the other intersection, the x coordinate here, I think, is about minus 1.6. And the y coordinate where they intersect down there, I think, is about minus 0.2. So that's my answer for part I. I've drawn the graph on and I've shown where they intersect, and I've read off estimates for those coordinates. Part II. Show algebraically that the x coordinates of the points of intersection of those same two curves satisfy that equation. Hence find the exact values of the x coordinates of the points of intersection. So we're doing this algebraically now. So I'm saying that solving these equations simultaneously, my 2x minus 3 is equal to x minus 2. Let's multiply both sides. So I'll get 2x plus 3 times x minus 2 is equal to 1. Expand the brackets. Collect up the like terms. And that's what we needed to show. Hence, I need to find the exact values of the x coordinates of the points of intersection. So I need to solve this equation now. To solve this, I'm going to complete the square. So I'm going to divide through by 2 first of all. I'm then going to complete the square. So I'm going to halve the coefficient of the x term, take away that number squared, take away a quarter squared, minus the 7 over 2 is equal to 0. The 7 over 2 is the same thing if I get a common denominator here, so let's times that by 8 to get a 16, times this by 8 to get a 56. Add the 57 over 16 to both sides. square root both sides. The square root of 57 is root 57. The square root of 16 is 4. And when I do that, I'll get a positive answer or a negative answer. Add the quarter to both sides. And I get that. But because I've got a common denominator there, I could actually write that as a single fraction all over 4. And there we go. So the 1 plus root 57 over 4, that's my exact answer for the 2.1. And the 1 minus root 57 over 4 is my exact answer for the minus 1.6. Right, so let's now move to part III of this question. Let me just get a bit of space by clearing all of this. Find the quadratic equation satisfied by y equals 1 over x minus 2 and y equals minus x plus k. Hence, find the exact values of k for which y equals minus x plus k is a tangent. Okay, so we are now going to do a similar simultaneous equations for y equals minus x plus k and the 1 over x minus 2 to work out the quadratic equation that satisfies the x coordinates of their point of intersection. So same idea, we're going to multiply across. We're going to expand those brackets out. So minus x times x is minus x squared. The minus x times the minus 2 gives me a plus 2x. Then we have the k times x and the k times the minus 2. Then we can collect together the like terms. And whilst I'm at it, I'm actually going to move everything to the other side here, because I don't like that negative x squared. I don't like the look of that. So I'm going to move everything over to the right-hand side. So I'm going to add x squared to both sides. I'm going to subtract 2x from both sides. I'm going to subtract kx from both sides. I'm going to add 2k to both sides, and the 1 stays wherever it is. Right, so this is the quadratic equation where these two lines would intersect. I need to find the exact values of k for which the straight line is the tangent. So that means that they would intersect in one place if it's a tangent, which means that this quadratic equation would have one single, so repeated solution, which means that its discriminant would have to equal 0. Now I can see that my a is 1. I can't see what my b term is at the moment though, because I've got 2 x's here. So what I'm going to have to do is to do a little bit of factorising here. So I'm going to rewrite this. So we'll 1x squared at the front. And I'm going to factorise the x outside. So it's going to leave me with a minus 2 minus k x. So just to check, I've got my minus 2 times x. I've got my minus k times x. But crucially now I can see that my b is minus 2 minus k. My a is the 1, and the c is the 2k plus 1. So let's substitute those into the discriminant then. So the b squared minus 4 times the a times the c has to equal 0 for this to be a tangent. Expanding this out, so the minus 2 squared is 4. The minus 2 times the minus k is plus 2k, but then we've got 2 of them, and then the k squared. Minus 4 times 1 is minus 4, and then we can expand. The minus 4 times the 2k is minus 8k. The minus 4 times the 1 is minus 4. Now we can see that these 4s are cancelled out. The 4k minus 8k is going to be minus 4k. I can now factorise the k outside. And I can see that if k equals 0 or if k equals 4, these are the values of k that will make the equation x minus x plus k intersect with our 1 over x minus 2 in one place as a tangent. So let me just show you what that would look like. So if I were to draw this onto my graph, with k being 4 first of all, so if I was to draw y equals minus x plus 4, it would have a y-intercept of 4 and a gradient of minus 1. So that's a long one, down 1. Which looks like that. And as you can see, that is a tangent. Or alternatively, if k was 0, so the y-intercept would be 0 now, I'd have y equals minus x plus 0. So it's going to go through the origin. The gradient would still be minus 1. And again, we can see that it does meet a tangent there. So this is why my y equals minus x plus 0, where k was 0, and this is the y equals minus x plus 4, where k is 4.